integral of, let's say, 1 over x dx. Okay, this is a fraction form. Correct? What's the answer here? What's the integral here? Or yeah, evaluate that. It will become. Allah, person. It is?
It's just -1, teacher.
-1.
Sorry, teacher. There's derivation.
Yeah. It is what?
Cannot, yeah, teacher.
Can. We learned about it.
C.
It is ln of absolute value of x plus c. Yeah, okay, this will come out during the test of Charson. So make sure to study. Yeah? Okay, so technically what we are doing is solving fractions, okay, or your algebraic expressions in fraction form. Now, for the examples I gave you last time, it's just on the simple side. Okay, it's a simple in the simple side. But not all algebraic fractions are simple. Okay, some may be complex, like let's say 4x minus 5 over 6x squared minus x minus 2, and you are being asked to integrate this one in x. Right? Now, yeah. Some of you, I saw your eyebrows go up. Oh my God, how will I do that? Okay, it's not as simple as like 4x squared plus 5 divided by x dx. Because this one, it's very easy. You can just simply 4x squared over x plus 5 over x dx, and then you integral, right? So no problem here. But this one is complex. It's a proper fraction. The denominator is bigger than the numerator. It's like you are working with a real fraction, like 2 per 3. Okay? This one, for this fraction, it's like you are working with like, let's say 8 per 2. The numerator is bigger than the denominator. This one simplifiable into this. But how about when we have something like this, a proper fraction? Okay. Now, to understand this one better, I'm going to teach you now a new technique. Okay. Let's set this one aside for now. And let me give you two algebraic fractions, two simple algebraic fractions. Let's say 3 per x minus 5, simple enough. And I want you to add it to, let's say, 4 over x minus, or x plus 2. Okay, I want you to simplify this fraction. What do we do?
We multiply the denominator together.
Okay, that's working with fractions. We multiply the denominators together. We will now have here x minus 5 kali x plus 2. Okay, recall your SMT days. Next, after this, what will we do?
3 will be multiplied by x plus
ini kali ini. So that will be 4 kali what?
x minus 5.
X plus 5. Good. Okay.
Minus teacher.
Okay, sorry. X minus 5. Okay, now that we know that, what's the next step? We expand, right? We will be getting 3x plus 6. So 3x plus 6 tambah 4x minus 20 bagi What's the bottom? X squared
X squared minus 20x
plus 2x minus 5x minus 10. Okay, so simplified form, final answer becomes, I can get 7x.
minus
Huh?
14.
It's 7x.
Yeah, teacher. The top one, you write minus
Oh.
4x. It should be plus 4x.
So 7x plus
Minus
minus 14 bagi berapa?
x squared
Squared
minus x
3x
minus
minus
3x.
x minus
Minus
3x
3x.
minus 10.
minus 10.
Okay, so this is now our complex fraction. These are our simple fractions, and this is now our complex fraction. The problem a while ago is, how do we turn it back? Okay, clear? How do we turn it back? Okay, so the process to turn it back to simpler form, okay, that means this is now known as your partial fraction decomposition. Partial fraction decomposition, this is now the process of breaking a complex fraction to simple fractions. Okay. Now, just like what I have been doing for the previous years teaching you. Okay, I can only show you. I cannot define it, but I can show you the process. Okay, so starting off with, okay, so please get familiar with the process. Okay, to get familiar with it, we start with this, our complex fraction. So we have 7x minus 14 bagi x squared minus 3x minus 10. Okay? So from here, since we want to break it, you always want to start by separating. Separate the denominator into its factors. Okay, remember what you did. To be able to combine it, you multiplied them, right? You multiplied the denominators of each fraction to be able to combine it. So now that we have the combined form over here, we want to separate it. And to separate it, we need to do factors. That means, what are the factors here? It's a bit cheating, but we already know the factors from a while ago, correct? Here. So this one now becomes 7x minus 14 bagi x minus 5 and x plus 2. Now that we have separated the factors or the denominator, the problem is, how do we separate the numerator? Okay, so this is where your partial fractions comes in. We just know that this comes from two different denominators. That is now x minus 5 and x minus 2. So the problem is, what will be the new numerator? What will it be? I do not know, so I'm just going to label it first. Plus. Okay. So I'm just going to label it with a variable, a and b. Okay. Clear? So now that we have it like that, I am just going to start simplifying it. Okay? We simplify. We simplify by multiplying it with the denominator. Okay? So kali x minus 5 kali x plus 2. What will happen here?
In the left side, it will cancel out. Meanwhile, on the right side, a will be multiplied by x plus 2, b will be multiplied by x minus 5.
Separate, then simplify. Okay, so obviously since I did simplification, this one will cancel. Inichoret. Chum. Leaving me with 7x minus 14 equal to, this one now will cancel, leaving you with a kali x plus 2 plus b kali x minus 5. Okay. Is everything clear so far?
Yes.
Because it's, yeah, sure, yeah. Next, once you reach this point, we now need to find the values of a and b, and we're done. But how do we find values of a and b? Okay, so to find values of a and b, you need to find values of x Okay, find values of x to turn the a term or b term to 0 to solve for a or b respectively. Okay, what does that mean? So, for example, if we want to solve for b, I want to solve for b, the a term, when I say a term, it's this. That's the a term. Okay? If that is the a term, obviously the b term is going to be this. Clear? So one of them must become 0 first so that you can solve for the counterpart. Okay? So, according to this, we find values of x to turn any of the term to 0. So if I want to make this 0, what will be x? Let x equal to what?
-2.
Negative 2. If I let x equal to negative 2 here, I will substitute all x's there. So that will now become what? 7 times negative 2 minus 14 is equal to a times negative 2 plus 2. Technically, this one now becomes 0. Okay, plus what's going to happen to the b? It will become b kali negative 2 minus 5. Okay, clear? So no more variables. A is removed as well. So what's left is b. So this one is going to be what? 20 negative 28 equal to negative 7b. So b is what? Equal to 4. Got it? Yes?
Yes, teacher.
Okay. That's not magic, yeah? Those are all logical operations. Okay, I will be erasing some parts of it, so I needed to paste part of it in the group. Okay, next, let me clear this one out. Now that we have now that we have B, I'm going to leave this because let's compare answers later. Now that we have B, it's time for us to solve for A. And I will start again with this one. I will get this original. This time I am going to work with the B one. So we let B equal to what? Let X, sorry, equal to
5.
5. If we do that, same. 7 kali 5 kurang 14 equal to A kali 5 tambah 2. And this one is tambah B, 5 minus 5, which is now again becomes 0. Okay, which gives us now, this is 21 equal to 7A, which gives us A to be equal to 3. Okay, so since you know that values now, you can now say that this part you can just put that. So A will be placed here, and then B is going to be placed there, and our final answer is going to be this one is equal to what's that? A is 3 per x minus 5 tambah B, which is now 4x plus 2, which is our original. Okay, got it?
Yes, teacher.
Okay, so that's for partial fraction. Which means now that, if you are given like integral of this one, okay, pay attention here, everyone, before I dismiss the class. If you are given an integral of this, then that means you need to break this into simpler fractions so that if you are able to break it into this, it's just simply integral of that tambah integral of this. Can you follow? Yes? And this one is now logarithm. Okay? Got it? Yes? Okay. More examples on integration. What's this one? Application in integration of partial fractions. Next meeting. But for today, I want you to work on the original problem that I showed you at the start of this class. Okay? Can you try breaking this into simple fractions using partial fraction? Okay? Break it first. I do not want you to take integrals of this one first. Just break it first for your practice. Okay?
Okay, teacher.
Okay. So that is it then. It's already time. So that means you can have your test. Okay? Goodbye, everyone.
And the teacher.